Hello, I'm Anna from Computer Science Department. I've come here to demonstrate on the program implementation of linked list using stack and queue. I've declared the header file and the namespace, and I've declared a structure name called node, and I've declared the structure members, that is data, and node pointer to next. So the address of this next will be stored in this next using the pointer, and the node contains two phases, that is data and next. Data will contain the element and the next will contain the address of the next node. And linked list is a linear sequential looping data structure, and the data here is dynamic, and I have declared the head is equals to null. So I've used a pointer, that is node pointer head is equals to null. If the head is equals to null, then the top, front, queue, rear, queue, and temp, everything will be null. And I've used a pointer for everything. And then I've used the conditions. I've used push, pop, and display, that is first for the stack. Push is to insert an element. I've used temp is equals to that new node. A new node will be taken, and the output will be like enter the data. And then the input is temp and the data which we have declared in the first, and then temp to the next, that is equals to the top is usually -1, and then the top is equal to be temp is to delete the element which has been inserted recently. Temp is used for that. And then I've used pops is to delete an element, so the element previously inserted will be deleted. And then if top is equal to null, then the stack will be empty, or else the stack will contain all the elements. If the stack contains all the elements, and then temp is equal to top, and top is equal to top to the next, and then the elements will be deleted, and the elements deleted will be from temp data. And then I have given the void display, that is to display the elements in the stack. If top is equal to null, then the stack will be empty as usual. If it's not equal to null, then the stack will contain the elements. So the condition is temp is equal to top, and then I've used a while loop here. So while condition is temp is not equal to null. If temp is not equal to null, then you'll have the elements displayed, that is temp from the data. From the temp data will display when the data from the next node also. Then I've used insert queue, delete queue, that is for queue implementation. Here I've used the same temp is equals to new node, enter data, and the same conditions are be applied for the stack in push and pop. Temp from the data, then temp to the next is should be null, and I've used the condition front queue is equals to null, and then front queue is equals to rear, and rear should be equal to the temp. So we'll add the rear queue to the next should be null. So the end of the statements is like the rear going to the next element should be null, and else statement also states the same, rear to the pointing out to the next is equals to null, but it shows with the other condition rear queue with the next is equals to temp, and rear queue is equals to temp. And then I've used void delete is to delete an element from that queue, so the previously added element can be deleted. I've used a statement called rear queue is equal to null, and if this is equal, the queue will be empty, else the queue will have the elements and it can be deleted accordingly to this condition. Temp is equal to front of queue, so the front should be equal to front of the next, so the element will be deleted. And void display, so in void display the rear should be pointing out the element, so the rear is equal to null, so the queue will be empty. If rear is not pointing out to the null, and then the queue has some elements and the queue will display all the elements, so the temp should be equal to front. Temp should contain all the elements, so that should be equal to front, so that can display everything. We used a while loop here. If temp is not equal to null, and then it will display you. I have declared the main function. So I've declared char, that is ch, int and n, and do while loop. I have used two do while loop. So one is outer for the to ask the user whether you want to choose stack or queue. I've implemented stack and queue together in one linked list. and then I've given the condition if n is equal to 1. 1 is stuck for the stack, and 2 is for queues, and 3 is for exit. And this push pop displays a do while loop separately for the stack 1. So I've given that. I've used a nested looping statement here. That is nested else if statement. That is n is equal to 1, and that will push n is equal to 2, that will pop n is equal to 3, that will display n is equal to 4, we get out of the program. And then I've used a while statement to ask whether the user want to continue. If you enter a wrong choice other than 1 to 4, it will show it as a wrong choice, and you can continue. You can press y or n, and then n is equal to 2. For that if loop, inside I have declared the queues, that is insert, delete and display. The same condition we have used a nested loop in the stack. I've used the same nested loop, same conditions, n is equal to 2, 3 and 4 in the same manner, and the same while loop, do while loop has been repeated here. And even for the end of the program, I've used the same condition, that is last one, n is equal to 3. The first one, if condition, n is equal to 1 is for the stack. Then second, if n is equal to 2 is for the queue. And third one, if n is equal to 3 for the exit. And ending, it will ask you whether the user want to continue. And this is the end of the program, and then you can give I don't want to continue. You can press any other key except Y. So now let's see the output. So here it comes. First one stacks, 2 is queue, 3 is exit, and enter your choice. I'm entering my choice as stack. I want to push first. I'm entering a data as 45. Continue. I'm going to push a data again, 56. I'm pushing a data again. I want to display all the data. So the data has been displayed. 78, 56, 45. I want to delete. I want to continue. Then I want to delete. Element is deleted. I want to delete it again. The previous element will be deleted. This is when the stack is fully full. And again I'm telling I want to delete. It's deleted. Now I want to display. Stack is empty. I want to continue. I'm giving 4. I'm getting out of that stacks. Now let's see about queue. First I want to insert. I'm inserting nearly 3 elements. And then I'm giving display. So the enter your choice 3 I gave, that is for display. Then 45, 67, 67, all the elements which I entered is being displayed there. And then I want to delete. Element has been deleted, that is the first element, because stack is stack is last in, first out, but queue is first in, first out. So the first element has been deleted here. To continue, again I want to delete. Then the secondly inserted element, that is 67, is being deleted. Again continue, I want to delete again. And now let's display all the elements. Stack is actually the queue is actually empty, but we didn't give a statement there whether to display or not, so it's not getting displayed here. So I want to exit the program. So this is the end of the program. The main thing of this linked list is it will have a node that will contain data and next, which will store the next address using a pointer. And then if you want to delete one element, you got to refer that address of the data in the previous box because it will be stored there. And this is how the linked list has been implemented using stack and queue. So this is the end of the program. Thank you.